The communication puzzle, why Azure Service Bus matters. In today's interconnected world, applications rarely exist in isolation. They need to communicate with each other, often across different platforms and technologies. This communication can quickly become complex, especially as systems scale and the volume of data exchanged increases. Building and maintaining reliable messaging infrastructure from scratch is a daunting task, consuming valuable time and resources. This is where Azure Service Bus comes to the rescue. It acts as a central messaging system in the cloud, simplifying communication between applications and services. By providing a robust and scalable platform for message exchange, Azure Service Bus allows developers to focus on building core application logic, rather than worrying about the intricacies of messaging infrastructure. Azure Service Bus is a fully managed platform as a service offering from Microsoft Azure that facilitates seamless message exchange between applications and services. It provides a reliable and secure platform for asynchronous messaging, enabling developers to build loosely coupled and highly scalable distributed systems. Whether you need to connect on-premises applications to the cloud or build cloud-native solutions, Azure Service Bus offers a comprehensive set of features to meet your messaging needs. Demystifying Azure Service Bus, a cloud messaging powerhouse. At its core, Azure Service Bus is a message broker. It acts as an intermediary between applications that want to send messages and applications that want to receive them. Instead of directly communicating with each other, applications send messages to Azure Service Bus, which stores them securely until the intended receivers are ready to process them. This asynchronous communication model offers several advantages. It decouples senders and receivers, allowing them to operate independently without being tightly coupled. This means that senders can send messages even if receivers are temporarily unavailable, and receivers can retrieve messages at their own pace, improving the resilience and scalability of the system. Azure Service Bus supports various messaging patterns to suit different application needs. Queues offer a simple first-in, first-out messaging model, ideal for scenarios where messages need to be processed in the order they were sent. Topics provide a publish-subscribe model, enabling one-to-many communication where multiple subscribers can receive and process messages published to a specific topic. In addition to basic messaging, Azure Service Bus provides advanced features like message sessions, dead letter queues, and scheduled messages. Message sessions allow grouping related messages and processing them sequentially by a single receiver. Dead letter queues provide a holding area for messages that fail to be processed, allowing for error handling and retry mechanisms. Scheduled messages enable delayed delivery, allowing messages to be processed at a specific time or after a certain interval. Core features of Azure Service Bus: building blocks of seamless messaging. Azure Service Bus offers a rich set of features that make it a versatile and powerful messaging platform. Queues provide a simple and reliable way to implement asynchronous messaging between applications using a first-in, first-out message delivery model. They act as a buffer, holding messages until receivers are ready to process them. Topics enable a publish-subscribe messaging pattern, allowing one sender to broadcast messages to multiple subscribers. This enables efficient distribution of information to multiple interested parties. Subscriptions allow receivers to filter messages from a topic based on specific criteria. This ensures that receivers only receive messages relevant to their specific needs. Dead letter queues provide a mechanism to handle messages that cannot be delivered or processed successfully. Messages moved to the dead letter queue can be inspected and reprocessed, preventing message loss and aiding in debugging. Scheduled messages enable messages to be scheduled for delivery at a later time or after a specific interval. This is useful for scenarios like recurring tasks or delayed processing. Message sessions allow grouping related messages and ensuring they are processed by the same receiver in the order they were sent. This is crucial for maintaining message order and consistency in stateful operations. When to employ Azure Service Bus real-world use cases. Azure Service Bus proves invaluable across a wide range of real-world scenarios. Microservices communication facilitates asynchronous communication between microservices, promoting loose coupling and independent scalability. Enterprise application integration connects disparate applications and systems, enabling seamless data exchange and process automation. Cloud to on-premises integration bridges the gap between cloud and on-premises systems, enabling hybrid cloud solutions and data synchronization. Internet of Things, IoT, handles high-volume message ingestion from IoT devices, providing a scalable and reliable messaging backbone for IoT solutions. Event-driven architecture supports event-driven communication patterns, enabling applications to react to events and trigger actions in real time. For instance, consider an e-commerce platform. When a customer places an order, the order processing system can send an order confirmation message to the customer's email address via Azure Service Bus. This decouples the order processing system from the email sending service, ensuring that order confirmations are sent reliably even if the email service is temporarily unavailable. Azure Service Bus in action, a simple C# implementation. Let's dive into a simple example demonstrating how to use Azure Service Bus with Net C# to send and receive messages from a queue. 1. Create an Azure Service Bus namespace and queue. In the Azure portal, navigate to Azure Service Bus and create a new namespace. Within the namespace, create a new queue with a desired name. 2. Install the Azure Service Bus NuGet package. In your .NET C# project, install the NuGet package. 3. Send a message to the queue using azure.messaging.service-bus. String connection string =, string queue name =, await using var client = new service bus client connection string, await using service bus sender, sender =, client create sender, queue name, service bus message =, new service bus message hello world, await sender, send message sync message 4, receive a message from the queue, await using service bus receiver =, client dot create receiver queue name, service bus received message =, await receiver dot receive message async console dot write line $received message / received message dot body, await receiver complete message async received message. This simple example demonstrates the fundamental steps involved in sending and receiving messages with Azure Service Bus using Net C#. Best practices for Azure Service Bus. Ensuring optimal performance and reliability. To maximize the benefits of Azure Service Bus, it's essential to follow best practices. Use asynchronous operations. Embrace asynchronous programming patterns to avoid blocking operations and improve application responsiveness. Implement error handling and retries. Handle potential exceptions gracefully and implement retry mechanisms to ensure message delivery in case of transient errors. Leverage dead letter queues, configure DL queues to capture and handle messages that fail to be processed, preventing message loss and aiding in debugging. Optimize message size. Keep message sizes as small as possible to reduce latency and improve performance. Secure your Service Bus namespace. Utilize Azure Active Directory, AAD, authentication and authorization to control access to your Service Bus resources. Monitor and tune performance. Utilize Azure Monitor to track key metrics like message throughput, latency, and error rates, and adjust Service Bus configurations as needed for optimal performance. Conclusion. Embracing the power of Azure Service Bus for simplified messaging. Azure Service Bus provides a robust, scalable, and secure platform for simplifying communication between applications and services. Its comprehensive set of features, including queues, topics, subscriptions, and advanced messaging options, makes it an ideal choice for building loosely coupled, highly available, and scalable distributed systems. By embracing Azure Service Bus, developers can offload the complexities of messaging infrastructure management to Microsoft Azure, allowing them to focus on building core application logic and delivering business value faster. Start exploring Azure Service Bus today and unlock the potential of seamless messaging in your cloud applications.